Hello, and welcome to this very special Davos agenda session, during which we will explore how space research, space investment, and the space economy affects our life on this planet. I'm Rebecca Blumenstein, a deputy managing editor at the New York Times. The global space economy will reach $1.4 trillion by 2030, and over half of the impacts from climate change are only visible from space. The Forum's Global Risks Report in 2022 warns of crowding and competition and the risks that result from a more accessible space. It seems that now, more than ever, establishing common rules between governments, business, and civil society on the use of space is an urgent challenge. To discuss these trends, we have a very, very special array of panelists. In a half hour, we will, for the very first time at the World Economic Forum, connect live to European Space Agency astronaut Matthias Maurer, who is currently orbiting the Earth aboard the International Space Station. We are also joined now by a unique panel of experts and industry leaders. First is Al Gore, the former Vice President of the United States, who's been at the forefront of bringing climate change to public attention for decades. And Mr. Gore was also at the forefront of establishing the International Space Station, which we'll hear about in a few minutes. Joseph Osbacher, Director General of the European Space Agency, which has sponsored the astronaut who we'll be talking to in a few minutes. Sarah Al-Amiri, Minister of State for Advanced Technology for the United Arab Emirates and chair of the UAE Space Agency, which last year launched a spacecraft to Mars. She also heads a team that's comprised 80% of women in the UAE. And Chris Kemp, founder, chairman, and chief executive officer of Astra, which is one of the many space startups that's out there now in an absolute investment frenzy that's happening on the space front. Vice President Gore, I'd love to start with you. You recently launched something called Climate Trace, which uses AI and space to actually bring accountability to climate change. Could you please explain how that actually works?
Yes, well, thank you for having me, Rebecca, and it's such an honor to join this distinguished panel. Climate Trace stands for Tracking Real-Time Atmospheric Carbon Emissions, and it is one of the new possibilities opened up by artificial intelligence and machine learning. We take the data, it's a nonprofit coalition, international, that relies on artificial intelligence to process data from 300 different existing satellites, coupling it with more than 11,100 ground, sea, and air-based sensors and multiple internet data streams to create unique algorithms that can give us a highly accurate and precise quantification of every significant emitter of greenhouse gas pollution. We released our first national inventory last fall in advance of COP26. Later this calendar year, we will have an asset level inventory. You will see, for example, at least the 500 largest emitters in every single sector of the economy, oil and gas, transportation, every ship, every refinery, every power plant, every factory, et cetera. And the purpose is to get real-time or near real-time measurement of where all this greenhouse gas pollution is coming from. There are more than 100 countries that do not have any inventory at present. The inventories even of the large countries are at least, in most cases, 5 years out of date. But now, with artificial intelligence, some things you can see directly from space. Methane, for example, there are a number of new satellites that will pinpoint methane. But the noise-to-signal ratio, the difficulty of measuring CO2 emissions against a highly varied CO2 background on the Earth makes it necessary to use artificial intelligence to get the precision that we need. You've heard the old cliche, you can only manage what you measure. We haven't had until now the measurements necessary to really manage greenhouse gas pollution. We're not the climate cops. We're kind of neighborhood watch, except our neighborhood is the entire world. And we're hoping that this precision will be of value. I know it will be of value to investors who are trying to green their supply chains and reach net zero, as so many companies are now. And the World Economic Forum has been one of the leaders in this movement, but also governments that in many cases do not have accurate information about where their emissions are coming from, and industry itself. Many of the companies that would like to make a commitment to net zero don't presently feel comfortable with their ability to measure their own emissions. We're going to do it for them, and every company will be accurately measured in near real time, and governments will be able to identify precisely the best strategies for quickly reducing greenhouse emissions. We've got to reduce them 50% by 2030 as a way station toward net zero by 2050.
So until now, we've really only had self-reporting, and in a sense, this is bringing radical transparency to emissions. And when is that report going to be out?
It'll be out at the end of the third quarter of this year. And yes, all of the emissions data at present derives from one single source, and that is the self-reports by some countries, the so-called Annex 1 countries, the developed countries, to the United Nations. They're out of date, they're inaccurate. We have already reported oil and gas operation emissions are at least double what they have reported. Rice emissions from some countries are 3 times what have been reported. There are many other really fascinating findings that have emerged already. And more than 100 countries have no reporting at all. They will soon have an obligation because of the IPCC and the United Nations process to join this reporting. We will be able to do it for many of these countries who don't have the capacity to do it on their own. But what's so unique about the space resource is we can see and measure and identify things from space that are extremely difficult to measure at ground level.
Joseph, could you please tell me, how does the European Space Agency plan to use this sort of effort in terms of space and monitoring climate change?
Yeah. No, thank you, Rebecca. And also, thank you for having me on this panel, and I'm very impressed also to listen to Vice President Al Gore. I mean, what he's saying is absolutely right, that we have an enormous need for information. We need independent information. We need information from satellites. And what we do in Europe, as you know, in Europe, we have a very, very green agenda in many countries. The green parties are winning votes and really are defining the new politics in Europe. We have the European Union's Green Deal. We have, in almost all the countries, a very clear goal of reaching carbon neutrality by mid of this century. So what we do from space is, and we call it sometimes, we are taking the pulse of our planet from space with our satellites, and we do exactly what Vice President Al Gore was just saying. We monitor, we measure the various parameters, and this is, of course, in the atmosphere, carbon dioxide and many other elements of greenhouse gases. But one has to never forget that the carbon cycle is a cycle which has, of course, the CO2 in the atmosphere, but also on the land surface, on the ocean. So this is a whole carbon cycle. So you need to measure, of course, the CO2 in the atmosphere, but also what happens on the ground, the deforestation, agriculture. It was mentioned by Vice President Al Gore that rice fields are emitting enormous amounts of methane. We have a permafrost that is thawing. Some call it a ticking time bomb. There's a lot happening there. So we have some of the world's leading Earth observation programs called Copernicus, but also with the Earth Explorers, and they really bring all this data to the people routinely. And I think it is fair to say that without satellites, we wouldn't know about climate change, at least to the extent as we know it today, because they feed the models, they feed the information we have, and we really create real information, and we avoid creating fake news because we have facts. These facts are really giving the status as it is. So yes, we are very active in this. We have a large program in Europe that looks to the various segments, and I'm very happy really to work very closely with many partners on the various aspects of climate, with the United States in particular, but also many other countries in the world.
Excellent. Sarah, I'd love to go to you. Along with the surge in private investment, national players like the UAE are also becoming very ambitious about space. Could you talk about what you see, how this plays out? Is this a UAE effort? How should we think about global cooperation as well?
Thank you, Rebecca. Overall, the UAE space program came on the back of international cooperation. New countries that are entering into space cannot do it without leveraging on know-how and experiences that are there around the world. And the purpose of it is twofold. One, it reduces risk significantly than starting something from scratch. But the other end of it is that collaboration and cooperation is part of new space and part of enabling new space. As our understanding and utilization of space as a technological resource and data resource becomes more and more vital across different key sectors. So we heard from Vice President Al Gore, from Joseph as well, the impact and implication that we have and the better understanding that we have due to having space assets in space. Currently, we will look at having better connectivity around the world, utilizing satellites that are now at a lower cost than current spacecrafts that are currently in orbit and providing communications. As we move forward, space exploration becomes important because what it does is it gives us scarcity. And in scarcity, when it comes to technology and high-risk platform, you're able to create high-impact science that we can realize the potential of it today, but more importantly, feeds into our development and understanding for decades to come, just from an initial investment. When we're talking now also on an international front, the dialogue needs to continue with regards to the sustainability of access to space, ensuring that nations around the world have the necessary access to have their assets in space. Secondly, to ensure that we're not cluttering space and creating another issue in space as we have today, monitoring sustainability here on Earth. And that needs global dialogue to ensure that we're doing it in a mechanism that is supportive to space development. And thirdly, something that was mentioned across the board, access to data, access to the analysis that comes out of it. If we keep space at the platform of only those that get access to data are the countries that own a satellite in space, we deprive a large portion of the world from the ability to get the necessary knowledge, the necessary evidence to action policymaking across the board, to get better crop yields, to get a better understanding on how do you sustain your production processes and what the real numbers are. And this is something that's happening across the board, and why we're focusing on the Emirates on enabling Earth observation from a downstream perspective, enabling entities to be able to analyze data from the satellites that are available around the world and be able to create the necessary solutions that touch on other sectors. Overall, Rebecca, we need to continue our dialogue internationally on how to transform space for policymaking and how to transform space into one of the technological tools for advancements across different sectors.
Excellent. And Chris, I'd love to go to you. Investment in space itself is soaring. It reached $7 trillion last year, doubling in just 2 years. What is behind this? We're hearing about billionaires going to space and space tourism, but is there inherent danger? Is this almost too much of a frenzy right now?
Well, I think that space is essential, as you've heard from Al and Sarah, to monitor the Earth, to understand the impacts that we're having on it, and the combination of all of these companies deploying various new sensors in space combined with AI will help us really understand the impacts that we're having, and also give us the ability to take action, influence our climate. Examples, Astra's partner here in San Francisco, Planet, has now launched over 200 satellites, and their entire purpose is to help us keep track of the environment, to monitor the planet, which helped Climate Trace, the consortium led by Al Gore, track emissions. There's been projects like the carbon mapping project, the Allen Coral Atlas. Astra's launching 3 satellites for NASA this summer out of Cape Canaveral as part of the Tropics program to help us better understand tropical storms. All of these companies are doing different things, and the value of the overall space economy is predicted to grow to over $1 trillion in just the next few years. We've seen this year alone, this past year, over a dozen companies either become public companies. We were the first space tech company to go public on NASDAQ this last July, but since then we've had almost a dozen companies either go public, like Planet on the New York Stock Exchange, or many others. So we've never seen this level of investment, and we've never seen this level of opportunity for the diversity of satellites and the diversity of sensors to supply us with new tools to help us manage and understand our climate.
So if I were a climate change activist and listening to all this, a surge of interest in space, and for a very good reason, especially in terms of accountability and measurement, is there some concern, and I guess this is a question, Chris, starting with you, but to all of you, is there a risk that all of this interest in space detracts from all the work that needs to happen on Earth to combat climate change? Do you see them as oppositional, or can they be mutually beneficial?
I see the majority of investment in space in Earth. If you look at companies like SpaceX, the capital being invested in these companies are largely being invested to create a more connected planet and a healthier planet, and a planet where we can better and more efficiently consume our resources and operate as a species. And if you look at all of the satellites that we've launched, they're largely satellites to help us connect underserved populations and to help us provide new tools to manage the resources here on Earth.
Joseph, is there a risk of, I know that regulators, that with Elon Musk, and you were quoted recently just being concerned about keeping pace with some of the scale of the private investment, and that Europe and other parts of the world could be left behind, and there could be overcrowding in terms of satellite. How concerned are you about that?
My concern is probably I'm concerned on one side, but let me start from the good part of it, and the good part being that we really do see, as it was mentioned just before by Chris, a new race in space. We had the race in the 60s and 70s during the time of the Cold War. Now we have a completely different race, actually between countries, between, say, the US and China as the two extremes, but also between the public and the private sector. And Chris, I think, is a very good example of what he has done and what he is doing very successfully, going from the commercial side. And this is something which is happening very strongly. We should never forget that the two richest people in the world are investing massively in space. And I think this is all great. And this is really something that creates a completely new environment, new opportunities with a lot of economic growth and a lot of technology advancements, which we all need. On the other side, and this is exactly what you have been just raising, yes, of course, because we do launch so many more satellites into space, which is great, because we do depend every single day, every single minute on those satellites for navigation, for telecommunication, for Earth observation, for climate research. There are so many domains where we really depend on them. But of course, if there are more satellites, this needs to be regulated, and this needs to be. We need to make sure that these orbits are clean and sustainable in the same way as we look after sustainability on our planet. And yes, there is a need for regulation. There is a need to make sure that these satellites are traveling. It's not only the satellites themselves, because once they are operating fine, that is not the issue. The issue is when they become, when they get out of their end of life, when they become debris, and therefore are a danger to other satellites in the orbit. Today, we have a huge amount of debris in the orbit. We have something in the order of 30,000 pieces, which are the size of a tennis ball or larger. This is a lot. And we are, even in ESA, we are constantly avoiding this debris and flying what we call maneuvers to avoid collisions with one of these debris. Even in the space station, we will speak in a couple of minutes to an astronaut, Matthias Maurer, after they came into the space station, a couple of days afterwards, they had to take shelter in the rocket that brought them there because of debris which was coming towards the space station. So yes, on one side, it's good to have all this activity. And for me, as Director General of ESA, of course, I'm very fascinated about this. And I do the same for Europe to build up a strong capability. On the other side, yes, of course, we have to regulate and make sure that this is used in a safe way.
Sarah, how do you look at this tension between governments and private industry and investment? You obviously are working for the government. How are you hoping to tap this interest in terms of investment dollars as well?
So in terms of the investments themselves, it's not about keeping tabs on the investment. It's like Joseph was saying, it's having a better understanding on how you manage space debris so it doesn't impact the critical infrastructure that we have in space. Because unbeknownst to everyone on a daily basis, you're using a form of satellite technology to just get on with your life, with your daily life. That is something that needs to be managed from an international perspective without inhibiting investments in space, without inhibiting development in space. Now, what the realm of investment allows for nations to bring in, and that's why it is embraced by governments around the world, is a diversity in technological developments. It's giving you access to different sensors at a lower cost than you would typically expect, because there's healthy competition when it comes to design and development. And this is natural to happen in any industry that eventually evolves into having a form of relationship between government and the private sector. Now, the roles are evolving. The role of the government is continuously to alleviate risks in development. Space is very risky and will continue to remain that way. So alleviate risks from businesses and therefore makes investment in space more attractive. And at the same time, developing capabilities and capacity in areas that you continuously need to evolve in. And that goes into technological advancements. That also goes into basic science exploration that gives us a better understanding in the world that our world lives in. And these two factored in together, I don't think we have a global answer on how do you continue the healthy investment that we see in space that's advancing technology at a much faster rate than we've ever seen it before. And at the same time, ensuring that the access to space remains open and remains unchallenging to access, and again, unchallenging to operate in.
Mm-hmm. Vice President, you were at the forefront of creating the International Space Station, which has led to a continuing effort on the behalf of many nations to cooperate when it comes to space. Could you talk about those early days and looking back on it, how it resonates today in the politically polarized world that we find ourselves in?
Well, with the tensions between the United States and Russia right now, in part because of the dangerous moves by Russia vis-a-vis Ukraine, it's useful to think back to a time when we were able to cooperate very together. In 1993, we began the so-called Gore-Chernomyrdin Commission. The former premier of the Russian Federation, Viktor Stepanovich Chernomyrdin, and I handled that binational relationship on behalf of our respective presidents for quite a long time. And one of our first ventures was to establish the International Space Station. And it has been a resounding success. We invited our European partners to join. Other nations have participated. And it is an ongoing international cooperative effort. And what it makes possible, along with the use of the space resource, I want to emphasize, Rebecca, the combination of the space resource with artificial intelligence. One of our partners at Climate Trace, for example, can use artificial intelligence to examine 45 years worth of Landsat data and can tell you the inherent fertility of every field on every farm on the entire planet. Chris mentioned a lot of the private companies. One of them he mentioned Planet. Planet Labs gives us a complete picture of the entire Earth's surface every 24 hours. It's a kind of a line scan. You have to realize that cloud cover obscures some areas on some days, of course, but there are multiple other companies that give us not only visual photographs, but in multiple wavelengths, so that we can measure greenhouse gas emissions, as I talked about earlier, but also a variety of other opportunities to cut down on chemical use that's unnecessary, on synthetic nitrogen fertilizer use that is wasted in so many cases. There are many other examples. We do have this problem with the debris in space. There needs to be international condemnation of any further anti-satellite experiments in space. Some of the debris comes from recklessness in that realm, and we have to. But the resource is amazing. We also years ago declassified what we call the GPS system. We take that for granted today, but it is incredibly valuable for all of us to be able to locate things on the Earth's surface, which was impossible until we began to develop space science.
Chris, could you talk about, you've been involved in space an impressively long time, and I've thought of the blue marble, which was such an iconic image for so many of us. Could you talk about your company, Astra, and just in 5 years, where you're trying to do more frequent launches to space, but where you hope you will be, where will we be just looking out into the future here if all goes well?
Well, the company that Al mentioned, Planet, was the first in now hundreds of organizations that now include nation states, space agencies, to have the idea that you could take a device the size of a loaf of bread and fly it fairly close to Earth and take very high resolution pictures, provide connectivity, put other kinds of sensors that help us understand the CO2 in the atmosphere. And there's been a revolution in space, not just an evolution, where satellites like the Discover satellite Al mentioned earlier would cost over $100 million, and they would launch on platforms like the Space Shuttle that would cost over $1 billion a launch. Astra now is at Cape Canaveral. We have our first flight here in the next week or so, where that flight was purchased by NASA for less than $5 million. I think it's by far, by maybe a factor of 10, the least expensive flight out of Cape Canaveral in history. And so the access to space has enabled a whole new generation of entrepreneurs to build companies, to take these companies public, to provide new capabilities. And so this innovation is something that is akin to the internet back 20, 30 years ago. And the internet was another one of these things where there was a time where you had to be a university or a government to be on the internet. And now you see tech companies spin up resources on a credit card, innovate and change the world. And I think we're seeing this kind of thing happen again. And to the point of managing the resource, we did it before. We did it with our airspace. We have millions of planes flying around, not colliding with each other. We did it with the internet, where we can't have collisions of names and addresses. And so I think what we need to do, and we've really pulled together, I think, some of the thought leaders behind the internet and behind some of the most pioneering companies. And we've started to ask those questions. What can we apply to how we've made this work successfully in other domains to space? And these folks are coming together, and we'll be presenting some of these ideas at the meeting in April. But I think we're just getting started here, and these are all solvable problems. We have a lot of incentive to figure this stuff out.
Does space tourism run the risk of sending mostly very wealthy people into space of kind of besmirching or taking away from some of these broader ideals and goals that you're speaking of?
Well, I think it's important to recognize that most of the investment in space is not in tourism, but it's in space tech, and it's in providing the tools that we need to help manage our planet, to connect our planet. This tourism business, there's only a few companies that are investing in this, and it's a small sliver of the overall value of the space economy and the overall investment in the space economy.
Sarah, I'd love to ask the same question of you. 5 years, you won a lot of accolades for launching the spacecraft to Mars, the UAE being only the 5th country, I believe, to do so. What's next? Where are you focusing on?
Two different aspects at the moment. One on developing capabilities across the private sector for us in the UAE. As we continue as a nation to diversify our economy, the space industry is one of the economies that we're focusing on. On the other hand, with regards to exploration, we're continuing our exploration mission on the back of the Emirates Mars mission, because of some of the outcomes that we've had, and we'll come back to it. So our next mission is one to the asteroid belt with a flyby by Venus. That's due for launch in 2028. That's going to look at the history of the evolution of parts of the asteroid belt, and more interestingly, looking at the evolution of the asteroid belt as a resource for space exploration. Now, when we talk about why we're moving towards two different angles, so there's exploration, there's also investments in the private sector here in the UAE and the development of capabilities for the private sector. The reason for that is that it provides us with the necessary capabilities and drive to ensure that science and technology becomes the basis of the UAE's economy in the coming decade, and make research and development one of the drivers. And the beauty of space is that it instigates and instills in society a deep understanding, because of its aspirational nature, a deep understanding on the benefits of science and technology technology for society at large and also for the economy. And through that, you're able to tap into the development and the adoption of technology across existing industries, ensuring sustainability also across existing industries, and you're able to catapult that forward. We wouldn't have been able to do this even 5 years ago without the Mars mission being in orbit. For us, it was a monumental shift in mindset, especially with regards to the appetite for risk. And this is what societally having a space program does. It increases your appetite for risk because the bigger the programs, the chances of success are lower and lower, and therefore your appetite for getting into endeavors that are riskier becomes higher.
I must say I was fascinated to read that over 80% of the scientists in your program are women. Is space becoming an area where women are focusing more?
Yes, we started about 14 or 15 years ago with our development part of our space program. And that meant that early on, we were a very young team. When we first started on the Mars mission, I think the average age was about 27. Out of the team. And what that helped is a true reflection of the outcomes of the higher education process, where in the sciences and in STEM at large, at that time, 30% of graduates were women. Right now, we're about at 40%. So the number of 80% of the science team being women, 34% of the overall Emirates Mars mission team being women is not really surprising. It was a natural reflection of where we were as a space program. And it was really interesting to understand that wasn't the norm as we went into the program and became more and more connected with the global science community. And for me, the agenda of women in STEM is very important from a global perspective, and diversity in STEM is very important from a global perspective, because that's how you ensure that you have innovation across the board and development happening without bias across the board.
And Vice President, very quickly, before we go to Joseph, who is going to shepherd us for the link to the International Space Station, where do you see this heading 2 to 5 years, if all goes well?
Well, I think we're going to see a tremendous expansion in the use of the space resource. And in addition to what Chris was talking about in these light payloads, Elon Musk has revolutionized the ability to launch heavier payloads with the reusability of the first stage. That's really a dramatic advance. And along with all these other developments, you're going to see a great expansion. But let me say, Rebecca, briefly, just to put this in perspective, the orbit of the space station is up above 250 miles. If you were going to drive a car straight up in the air at Autobahn speeds, it'd take you most of the day to get there. But if you were going to drive to the top of the sky, it would take you about 5 minutes. And below you would be all of the greenhouse gas pollution. It's a very thin shell surrounding our planet. And we're currently filling it up with 162 million tons of man-made global warming pollution every single day. We're using that thin shell as an open sewer. And that's what's causing the crazy and dangerous weather extremes and threatening the future of human civilization. We have to stop it. And the space resource will give us the ability to measure where it's coming from and to give us the tools to manage the sharp reduction in this greenhouse gas pollution and save the future.
And with that, we are going to thank you to the panelists, and please hang on, because after the interview with our astronaut, we will come back to you for your observations. And I'd like now to turn to Joseph, who is helping to organize the live stream with your astronaut in the U.S. A video feed from Houston should be shown on the screen now as the connection is being made. Joseph, could you please explain what's going on here as we work to establish the link?
Yeah. So what's going on? So we are actually connecting with the space station. Vice President Gore was
Space Agency. This is
was
Mission
really
Control.
recalling some of the highlights of it. The space station right now is somewhere over the Pacific. It's somewhere halfway towards Latin America, which will be the next landmass it will hit. And I just heard some sound. I think we are connected to Houston.
And Joseph, like European Space Agency Director General in Davos, I can hear you loud and clear. This is Matthias Maurer, astronaut on the space station. How do you read me?
Very good. Hi, hello, Matthias. Very nice to hear you. Very nice to see you. As always, you're in good shape. You have a green T-shirt, which is the color of our discussion today at the panel. So really appreciate. So how are you doing, and where are you, and what have you been doing just now?
Yes, so I'm doing fine. I'm doing well. And this morning I was actually involved in a lot of cargo operations. We fill our vehicle that we sent back. Actually, I think cargo is the wrong term. I should say it's our harvest vehicle because it's full of scientific experiments, results. We worked hard in the last weeks and months. And now we bring this harvest back to our planet Earth for the scientists to analyze all these samples that we have produced up here in space and to produce science and knowledge for humanity out of it. And right after my cargo activities, I also did some sports, and that's why you see me probably like clean and in good shape now, because I just had my kind of a wet towel shower.
Fantastic, Matthias. As you know, we are here connected through the World Economic Forum's virtual space session. And I would like to hand over to Rebecca Blumenstein, a New York Times Deputy Managing Editor, and she will moderate this session with you. So Rebecca, over to you.
Thank you, Joseph, and hello, Matthias. It's so good to see you.
Hello, Rebecca. It's wonderful having the opportunity to talk to you from space and hopefully to have a very nice exchange also about a very important topic.
I must say we were debating whether we should say good day, good evening, good night, and because you orbit the Earth every 90 minutes, it's a bit of a real-time call. But I'd love to start out by asking, how have your views of the planet changed since you have been aboard the International Space Station?
Yeah, so you're right. We circle our planet like every 90 minutes, 16 times a day. And we work according to the UK time, so Greenwich Mean Time. So we're only 1 hour offset of you. And yes, I traveled the planet once before, like it was a round the world trip. And that was always my big dream. And this, like seeing the world, changed my life. And it gave me a lot of different attitudes, like how we should work with our planet and the people on our planet. But now being in space, and especially this morning when I did my sports activity, and while doing sports, I can look out of the window and I see down there our planet gliding by. I saw Latin America, South America gliding by, and a few minutes later, less than 10 minutes, we were over Africa. And it crossed my mind that Christopher Columbus took this journey just in the opposite direction like 500 years ago. And for him, it was a really tough adventure. And he had his 3 ships and his crew, and everyone needed to work hard to make this one challenge possible. And nowadays, I look at from space down there, and for me, like space is like our planet Earth. It's one big spaceship. And I think like the tripulation, the crew of our spaceship Earth is like the crew of a ship of Christopher Columbus at that time. We all need to work together in order to meet the challenges of our day, like climate change, for example. So I've been here in space and I've fallen in love with our planet even more than before.
And how does the work that you do help the environment? And what would you say to some people who say we're focusing a bit too much on space and not enough on the Earth?
Yes, I think like space cannot be the only solution to have a solution for climate change, but space is definitely a very, very important aspect. And I see 3 different layers to it. For example, like we have the personal layer, like every individual needs to contribute, and space is a big motivator. When I talk to the kids, I can motivate them and I can describe what I see. And we also have the technological layer. For example, we need to improve our technology to create less CO2, to have more efficient machinery, more efficient transport. And here on the space station, we do a lot of research to produce these new and innovative materials. And there's also the political level. And I think you are today there in the political level discussing such problems. I think the political decision makers, they need to have the data, and the data comes from satellites, and it also comes from the science that we do in space. For example, we look at the Earth with the satellite data that we provide to you, but we also prepare exploration. And exploring space means also looking at different planets, like planet Mars, for example, who used to have an atmosphere and a lot of water, but now the water is gone. So obviously there was an extreme climate change over there. And so space can bring in a lot of knowledge and feed all this information into the decision maker so that you can take the right decisions.
Vice President Gore is on our panel, and he played an instrumental role in creating the International Space Station. Could you please talk about just what cutting-edge research you're doing? You mentioned your cargo work before, but just what is your goal for this week or month up there?
So I'm working here during 6 months in space, and I would say like between 100 and 150 experiments I will be participating in. And it's a large spectrum. For example, it involves a lot of life sciences. You all know that humans in space and zero gravity, that it has a lot of changes. The muscles and the bones like they dissolve and get weaker, and that is much, much faster than on planet Earth. So actually like the loss of bone mass happens up to 30 times faster than on the ground. And so astronauts are kind of guinea pigs, and we can study in a very controlled environment, in a very fast way, very fast progress, like how to fight such diseases. That can be done by nutrition, by medication, but also by doing sports. And I have a very interesting experiment, which is called myotones. And in this experiment, I can measure the strength of several muscles on my body, and then we feed this information back to the scientist, who then prescribe us countermeasures. For example, I have a suit that provides me small electroshocks, and it also comes from rehabilitation. And this all will feed back and help elder people who who have problems with their body, like muscle problems, bone problems, to remain longer time fit and healthy, or once they are in hospital, maybe to get out quicker from the hospital. But I also have very interesting experiments that are correlated to like the pandemic, for example, like Corona pandemic. We all know transmission of diseases is a very important topic, and I have here new metals, new alloys that I brought to space that are modified on the surface and that they kill bacteria. And especially here in space, with the space radiation, the mutation rate of bacteria or like microbes is faster. And so the scientists will learn a lot how these new surfaces behave here in space in this controlled environment. They can analyze it, and hopefully we can transfer this knowledge also then into everyday life. For example, in hospitals where surfaces that everyone touches, and then it's like a surface that is prone to transmit these microbes from one infected person to the next healthy person and infect him, that we can stop this chain and cut this chain. So it's very important. Then we have Simon, which is artificial intelligence. Once we fly further away from the Earth, I will not have my Houston ground control team, or in Munich, in the European ground control team, who looks over my shoulders and steps in if I do a small error or if I have a question. So artificial intelligence is really important for exploration in space, but also on the ground, it's very important also to increase efficiency in all like ways of transport, or also space transport management. Then we have experiments that are also related to reduction of CO2. We have concrete hardening, a very interesting experiment that looks into a seemingly very old material, concrete, which we have everywhere around us, but not in space usually. And but during the production of concrete, we produce a lot of CO2. And so if we can improve this process by a better understanding of the process, we can actually cut down also the CO2 emissions, and that will be very significant.
You sound very busy. I would love to hear your views about space tourism. Do you think it's a good idea for more people to have the experience you're having now? And I would also love to know, what do you do for sport up there, for sports?
Yeah, for sports, we're not playing football here for sports, but we have three different devices. One is like running, it's like a treadmill. So I'm running, but actually I'm chained down to this machine that puts me with a certain force on there. And so the force that I have here is like almost like the gravity force on Mars. So I'm always having my Mars jog here on the space station. And then we also have a bicycle without a saddle, because we don't sit, we just float there. And we do a lot of the work just with the legs, like pulling and pushing. That's for like cardio activity. But then we also need to do sports that tells a lie to our body, namely like telling like you need your bones and you need your muscles. So we need to do weightlifting. And obviously in zero gravity, you don't lift any weight, but we push against a pressure that has the same effect like weightlifting on the ground. And that is very, very important. And since we have this new machine, like the health status of astronauts in space has become much, much better. So, and the other question, remind me please again.
Space tourism, do you think it's a good idea for more people to have the experience of looking at the Earth the way that you get to every day?
Yes, obviously, like space tourism is like it's a two-sided like knife. It has one positive side, like the more people fly to space, the more ambassadors we have that hopefully come back to our beautiful planet Earth and say like, we need to take care of our planet, we need to reduce the emissions, we also need to stop everything that I see here from space and that makes my heart bleed, like burning rainforest, or like the melting of the glaciers, like all these phenomena we can see here from space, also the flooding last week in Brazil that we could observe here from space, that are clearly evident. And I think everyone who's been only a few days in space will become a really avid ambassador for our planet Earth and to protect it in the future. On the other hand, the more people we fly up here, the more rocket launches we will also have. And so we create also waste and space debris. And here that's a very important topic because on our planet Earth, we ignored for way too long that the open seas, the oceans that don't belong to any country are still important. So we shouldn't like put our oil there or our garbage there, because in the end, it will end up in the food chain. And we had to learn this. And the same happens now here in space. We fly to space, or like already have been flying to space for 5-6 decades. And now we see that every time we launch a vehicle to space, we leave space debris, and that piles up. And in the end, either we actively clean space, or we will have the same problem that we have on the ground with too much garbage, and like people get annoyed by it. Here, it actually gets a safety issue. And so we need to take measures to make sure that space is clean and accessible also in the future for everyone. Because you will not want to live in a world where space is not longer accessible. Our economy, our daily lives depends way too much on everything that we have here in space.
With all the new satellites and the space debris you mentioned, is it becoming dangerous to orbit the Earth in the International Space Station? Joseph was saying earlier that there was an incident recently where you actually had to take shelter.
Yes, so we had always had like space debris issues. It comes from the early rocket launches, but it's also we have natural space debris because there's also like stuff coming from the universe and entering the atmosphere, and that's passing also our orbits. And so space flight is risky, but if we take the right measures, I wouldn't say it's dangerous. For the International Space Station, we have a lot of ground control teams that like measure the area and the space that we're flying in. And if there's any object coming close to us, we will take measures. So one measure could be that we do a debris avoidance maneuver, which usually means like we start up our engines and we lift the space station a little bit. Sometimes we also need to slow down and lower the orbit a bit just to dodge away from the object. If the object comes on a very short notice, then we need to go into shelter, which means like we hide in our spacecrafts and close all the hatches between the different modules just in case that something happens. But I think so far everything went well, and the flight controllers have a very good situational awareness. But the more rockets we launch and the more stuff we bring up to space, I think we need to have rules, strict rules, who needs to do an avoidance maneuver. For example, if we have a collision upcoming between two satellites that can be actively controlled, because everyone who dodges to the side burns energy and reduces the lifetime. So basically, it has also directly an economic impact to do so. And ESA is in a very good position, and we have like people, experts in ESA working in the Space Situational Awareness Program. But I think that is a question that also Josef Aschbacher, the Director General of ESA, will probably have mentioned already or will raise awareness again, because it affects everyone, not only ESA or NASA. It's everyone who's active in space.
You've talked a lot about cooperation. Just to wrap up, how do you think, if you're talking to people, we have a very global panel, there's people tuning in from around the world, how can we ensure cooperation on common rules for everyone on Earth for the beneficial use of space?
Well, I think we can look at space. The International Space Station is really inspiring. I mean, we launched this project 21 years ago, and people have been living here ever since. People from a lot of different nations, different languages, different cultures, and it works. We all work together. We are one team, and I wish we could extend this cooperation, this success, on to many more projects, and also especially to the very important projects like fighting climate change. And so I think we can inspire people and say, like, look what we have achieved with the International Space Station, and let's go an additional step also in other topics.
And finally, climate change is obviously such an urgent issue here on Earth. Do you think that you mentioned the fires and sometimes the flooding that you see, you feel like you can actually just with your eye see the impact of climate change from space?
Yes, I mean, when we fly around the Earth like 16 times a day, we cross over areas that are very arid, very dry, and I can see scars on our planet Earth where people dig deep into our planet just to extract resources. So we're actively reshaping our planet. We are cutting down trees, we're burning down rainforests. So I see the flames, and I see huge areas of agriculture where like generations of astronauts before had seen a nice intact rainforest. So also the glaciers are getting smaller and smaller, but I mean, the satellite photos provide here much better imagery for this one, because you need to look into long term, and my 6 months here in space is probably a little bit too short. But also see areas of flooding. And so we astronauts here, we can be communicators and communicate this to the people, because data is one aspect, but having an ambassador who tells it is another aspect. And we are actually also contributing here in producing technology that hopefully is helpful against climate change. For example, we are preparing the exploration of the Moon and Mars. And in order for this exploration, we need new technology. We need to have closed loop chains, for example, the water loop. We recycle all the water that we have here on the space station up to roughly 91, 92%, I believe. But in order to be successful in exploration, we need to come up to 98%. So, and all this technology that we use and develop for space, we then spin off to the ground and then help to produce clean water on the ground and have more efficient like closed loop systems. And I think that's a very important aspect. And also like looking at energy production, we use solar energy here on the space station, and solar energy has been like developed in the past quite a bit for space applications, and now it's the game-changing technology also on the ground to fight climate change.
Well, I want to thank you so much for your time. We learned so much talking to you, and best of luck up there. You're doing very impressive, important work. Take care.
Well, thank you very much for giving me the chance also to communicate about this very important work. And please keep on going, discussing the very important topic about climate change. And we all need to contribute. All the best for your very important work.
Thank you so much, Matthias. Take care.
Bye, Matthias.
Station, this is Houston ACR.
I'd love to hear from our panelists what your impressions are listening to him and what he's doing with his days. He's very vocal about the need for international cooperation, concerned about space debris. Joseph, let's start with you.
Yeah, no, I mean, it's always fascinating. Of course, we do talk to astronauts occasionally, but every time I hear an astronaut speaking, it's just so fascinating because they are ambassadors, as he says. I mean, we are also using satellites, and with the Vice President, we spoke before about the use of satellites to measure climate change. More than half of the parameters to understand climate come from satellite data. But it is not comparable with the voice of an astronaut, of a human being who looks there, gives you an impression of the deforestation, of the fires that they see, not only over Africa and over the tropical areas, but also in the northern parts. And this is always amazing. And I'm so happy to hear this voice because it gives us the perspective how to see our planet, because we all know it, and really so happy that we have Vice President Gore with us, who has been telling us an inconvenient truth, and we have to tackle it, and we have to look into this. And I think the combination of technology from satellites and astronauts is fantastic.
Chris, what were your thoughts as you're listening to him?
Well, I think there's a moment we have now that has not ever existed in human history, where space is now accessible to entrepreneurs, to the private sector, in a way that has never been before. And we can now invest in these companies on public markets for the first time in history. We now have the opportunity to build sensors and put them in space to help us see our planet for the first time. So we're beginning an era of innovation like we've never seen before. And so I'm incredibly excited and honored to be a part of that, and to enable all these entrepreneurs through Astra to get all their new satellites into space, and then to make it easier to operate in space. I'm excited about what Elon's doing that could potentially take us beyond Earth to Mars. Excited about all the space tourism stuff that Jeff and others are working on. This is truly a moment in time where, if we embrace this, if we tackle the hard problems of how we manage space debris, how we manage the spectrum, the precious spectrum that we need to use efficiently, we can make humanity far more efficient in our resources, use of resources here on Earth. We can reduce the carbon emissions in the atmosphere. We can hold people accountable that don't help us with these objectives. So we're just getting started.
Sarah, to you.
I follow on Chris, we're just getting started. Space is opening up to even more and more innovators and a better understanding on how to connect it across different sectors, so that you're moving it from the realm of being something that is highly specialized to a small group of nations and a small group of individuals, to a tool that is accessible to the masses. And it's through that you're able to increase investment in it, be able to get the right answers to complex questions utilizing space, be it through the International Space Station, using satellites, getting a deeper understanding on our universe at large. Space is here to be both impactful to the economy. It will continue to be a major driver of scientific knowledge, and it will continue to be an area by which we need to continuously invest in and continue it from a perspective of international collaboration.
And Vice President, if you could please close us out with some final words on your observations.
Well, thank you, Rebecca. I loved your interview with Matthias, and as Joseph said, seeing through his eyes the views that are only available from space reminds me that actually the first time we as human beings saw our planet whole in space was in December of 1968, before the moon landing, when the first mission went that far out into space around the moon. And in many ways, the modern environmental movement began when we were able to see our planet floating in the dark void of space. And it brings a new consciousness and a new awareness. I might just mention that 1 million miles on the other side of the Earth from the sun, 1.5 million kilometers, the James Webb Telescope is unfolding right now, and will give us a chance to see into the distant past, to see the first moments of the universe's emergence. But we have to use our moral imagination to see the future of humanity, and to see the grave danger that is posed by all of the global warming pollution that we're putting into the atmosphere every day. It's trapping as much extra heat every 24 hours as would be released by 600,000 first-generation atomic bombs exploding every single day. That's what's threatening our future. And by using the space resource, we will be able, with Climate Trace and other initiatives, to be able to get very precise in finding out exactly where this pollution is coming from, and then encouraging, by whatever means possible, the sharp reduction of the global warming pollution that's threatening humanity's future.
Well, we look forward to that report and so much to come. And I'd like to offer a special thanks to Matthias and to all of our panelists for most memorable and historic discussion. Thank you all so much.
Thank you.